Hello everyone, in today's episode we're going to be analyzing a memory dump from a Windows file system. We're going to be using mainly Volatility 3 and we're going to be solving the CyberDefenders Ramnit Lab. I chose today like an easy lab because the memory analysis is like a very broad, if you want, like topic in digital forensics. So I'm going to use this as like an intro for memory analysis, and then we're going to build on top of that and probably in the upcoming videos. So let's get straight into the lab, and basically we're going to be analyzing a memory dump using volatility. This scenario, basically there is an IDS that alerted about a malware, and our task is to analyze this dump. And the dump exists. Basically you download it, you extract it using the cyberdefenders.org password, and let's go straight into it and start solving it. So the first question is, what is the name of the process responsible for the suspicious activity? And I like this question because it makes you, like try to think and try to find the reason why this process is suspicious and which one is it. And for you to be able to figure that out, you have to understand what is evil and in the process. So we have multiple criteria to determine if a process is suspicious. One of them is a parent-child relationship. So we're gonna start with that. Let's start step by step and see what we find along the way. So I already have the memory dump in here, and basically we're gonna start doing everything from scratch. So let's start. So vol is basically the volatility command. -f is basically which file we want to, which memory dump we want to analyze, and then we're gonna do -r pretty. It's basically telling volatility, give me this output in a very nice way, pretty output basically. And then we're gonna do a plugin, which is ps3 plugin. And at the end, I'm gonna basically forward everything to a file. I'm gonna call it ps3.txt. The ps3 in here basically is a plugin responsible for volatility to go and scan the memory dump, check the parent child relationship, and then we're gonna see the output, and then we're gonna see if there is a process that seems out of ordinary. And for example, like if you see from a MS Edge a PowerShell.exe coming, then yeah, it's probably suspicious and we should look into that more. So let's go straight into it, and then we're gonna be able to analyze that better. So I'm gonna run the command. Okay, it's done. So right now we have the ps3.txt file. I'm gonna use nano to look into this file, and let's go straight into it. So this is a ps3. You have the PID, PPID. You have basically the name of the executable, the offset, virtual offset. You have the threads, handles, session ID, and you have create time and exit time. So if you notice here on the left, you have those asterisks or stars or whatever you want to call it. So when you have one star, it means that's like if you want, like the first parent. And then the two asterisks is the child of the first asterisk. And how can you make sure that it's actually the child or the parent? So you can associate it with the PID and PPID. You can notice that all three of those processes have the same PPID, which is basically the same system process in the beginning. So we're gonna take like a quick look into it. As you can see, most of them are SVC hosts. 660, for example, it should have a services.exe as a parent, and it is. So you can see that in this case SVC host is 3 stars and services is 2 stars. And then what is the parent of services is 524, which is basically when init. And we're gonna continue with to see if we can find something of interest. Right now nothing is really catching my eye. And then we get to the end of the file and we see basically that We have a logon.ui.exe. Basically, it means that the user logged in, and that happened around 1948. Login UI is basically like the UI that you see when you want to type your password in Windows. And you can see that the parent is 624, which is when log on. Then you have user init. If I'm not mistaken, that's basically when the user log in and put the correct password. And then you can see that basically login.ui is started at 24, and then user init is 26, along with explorer.exe, which usually starts whenever a user log in. And when you see a process, any of those processes with the parent of where the parent of that process explorer.exe, most of the time that means that whatever the whoever the user that logged in, those processes are initiated by that user, like on their Windows. So right now nothing really stand out. Like, it's normal for people to, run OneDrive, Chrome setup.exe from the name by itself. It doesn't seem suspicious or that suspicious yet. We're gonna see more when we try to look for more evidence of suspicious processes. So I'm gonna exit, and we're gonna now look at another criteria to see if a process is malicious, which basically to check the path. Path is important is because it lets us know where that file came from or where it exists in the file system. And we're gonna basically check the command line, and the command line plugin in Volatility will give us both the path and if anything was given to that process as argument. So it's like two birds and one stone. So if you see, for example, a process that usually don't take an argument and then it's taking the command line, then maybe you're like, okay, maybe there's something that I should look more into here. So to do that, we're gonna do the same thing as we did before. We're gonna remove the -r query, and we're gonna do Windows cmd line, and then we're gonna put the output in cmd line.text. So let's run that. Okay, it seems to have done. Let's check. Let's do cat cmd line and check what we have in here. So when I look at this, first I don't like to see, I don't want to, because I want to minimize. There is a lot of output. I want to, like, check if there is something that will strike as anomalous in an easy way. Let's try to see if we can find like a low-hanging fruit. One way that I like to do it is I like to do a grep, and then I like to do basically a reverse search, which basically whatever I'm gonna type in this string is gonna give me everything else. In this case, I wanna filter out everything that is related to system32. The reason being is usually the executable within system32 are executables that are installed by the system. So I'm not saying that there could be no malicious executable there, but to be able to put an executable in a system32 folder, you have to have admin privileges, which is pretty, no, I'm not gonna say pretty hard, but which is basically more difficult to do. And since we're looking for like low-hanging fruits, so we're gonna first start with removing system32. So I'm gonna run the command, and we're gonna see now everything, like, we have way less, like, output. So let's take a look at what we have left. So we have win init, which and win logon, which related to basically authentication and logging in inside of Windows. We have task host, everything. However, something strikes me as odd already. And maybe you don't realize it yet, but this one strikes me as odd. The reason being is that first, the file, like this crom setup.exe, it's in the downloads, which most probably means that this user called Alex downloaded that malicious or suspicious executable and then run it, which is most of the time what happens in organization. You have users clicking on phishing links, downloading something, and then run it from there. So, and nothing else strikes me as suspicious. So I'm gonna go ahead and put Chrome setup as our suspicious malicious. Let's see if CyberDefenders find it to be correct. I'm gonna write it. So Chrome setup.exe, and here we go. It's correct. Now the second question, we already have the answer. What is the exact path of the executable for the malicious process? If we go back, we can see the command line, and to our luck, we can see that basically this is the full path, and we're gonna put it immediately in here, not to waste time. So C users Alex downloads Chrome setup.exe. .exe. And we solved already 2 questions basically from one plugin, which is, I like it. I really like it. Now let's go ahead and check the third question. Basically, we have to figure out what communication this malicious process did. And to do so, we have to use basically there's a plugin Volatility that scans all like active communication, I would say, in the memory. So the plugin is called NetScan. So to do it, we're gonna basically do NetScan with Volatility. And to do so, we're gonna have to do like this. And then I'm gonna output everything to netscan.txt. The reason why I like to put them in files is because I don't want to run the command again. I already have the output. So if I want to find something real quick, I just do a grep on that file and I'm done. So I'm gonna run the command and we're gonna wait for it to be done. NetScan takes a bit of time because it's trying to scan the memory dump for all the objects that are related to network sockets, and that's usually take a bit of time. So it will take you maybe a couple of minutes for the plugin to finish, and it's already done. We can see that we have a netscan.txt in the folder where you are analyzing. And I want to show you that basically you have an offset, you have which protocol, TCP v6, TCP v4, UDP, whatever. We have local address, basically your local address, and then you have local port, you have foreign address, foreign port, state of the socket. So it could be established, closed, listening, whatever. State, PID, the PID, which process ID was. You have the owner, who's the owner of that process, and you have when it was created. And since we already know that, I'm gonna go out, and since we already know which process is malicious, so we're gonna try to grep onto that. So I'm gonna do grep -i. -i, it means case insensitive, and I'm gonna put here Chrome setup, and then we're gonna have 3 entries. You can see here it's on TCP. You can see as well that basically you have on port 5202 communication coming from that port toward that port, or from that IP toward that IP. So our answer is actually that. So let's try to put it in CyberDefender, see if it's correct. And conveniently it is. So let's move on to question 4. To determine the specific geographical origin of the attack, which city is associated with the IP? Usually you can use whatever, like OSINT related to IP geolocation. I prefer to use ipdata.co, and you put the IP, and in this case I got Hong Kong, and so it should be Hong Kong, and it is. Let's continue. Hashes serve as unique identifier for files, assisting in the detection of similar threats across different machines. What is the SHA-1 of the malware executable? So to tackle that, we have to first get the executable and then to hash it. How to get the file? The way to do it is to first do a scan on the memory. File scan, basically. So Volatility will go and scan the memory for all known like file headers, and then basically we will see which files we have. So to do that, we're gonna do Windows plugin file scan, and I'm gonna, like usual, forward it to a file scan.txt, and let's wait for it. So just like netscan, file scan also take a bit of time, so we have to be a bit patient with that. So like I said, it can take a minute or two, so wait for it. It's not like it's stuck, it's just scanning and we are waiting for the output. In the meantime, the idea is once Volatility know where the file is in the memory, it has an address, and we're gonna use that address to actually dump the executable from the memory into our file system. So now let's check the file scan.txt and try to grab -i, and we're gonna do chrome setup. And basically the first those hexa characters, this is basically the virtual address inside of the memory. And to dump it from the memory into our file system, we have to use the dump files plugin, and then I think we need to do virt add like that, and then we're gonna take the address. I think anyone would work, but we'll see, and then we run. And as you can see, we have an error here in the data section object, and we actually have like an image in here. So let's see if that works out. ls-l, and we can see here that basically we have two files. We have the .image and .dat. The .image comes from the image section object of the memory, which basically is the actual executable, where the data is basically all the data that the executable used to execute the process. In this case, we are more interested in the .image, and to actually get the SHA-1, we have to use SHA-1 sum, and then we're gonna give it the file, which is the image one, and we're gonna press enter, and this one here should be the SHA-1 of that executable. So let's test it out, and it is correct. Now examining the malware development can provide insight into its deployment. What is the compilation timestamp for the malware? So the compilation timestamp is basically when was this executable compiled from machine code into an executable. So I think this can be forged on an executable. However, it's still important to go and check it out. The reason being, if an attack is happening on your organization and you want to know if this threat actor is using an executable specifically tailored for you, the compilation time of the executable will be something near to when the attack happened. However, if you see like a compilation time of 6-7 years ago, it means basically that this threat actor is just using a, if you want, like a template malware, and he's probably using it on multiple like of his victims. So to actually get that timestamp, you have to use exif tool, and we're gonna give it the image.image file. So to do that, we're gonna do with that, and now we have all the information. The timestamp in here means the compilation timestamp. So this is basically the answer, or at least I believe it. This is the answer. So we're gonna put it here. Let's make sure it's the right format. So dash, and let's check the hour and the minute. I think this one is 8:36. So put 08:36, and it's correct. Now for the last question. Identifying the domain associated with the malware is crucial for blocking future malicious communication and detecting any ongoing interaction with those domains within our network. Can you provide the domain connected to the malware? So usually, depending on your luck, you can either to get that domain that they are communicating with, you have to do two things. You can do actually three things, I think. First, we saw that we have a IP. This one. One thing is you can go into your DNS logs, check if there is any query from DNS that resolve that IP. You can know the domain. Another way, you can do a reverse engineering, which basically is you tell someone with reverse engineering skills, go and check if you can find which domain it's communicating with. Another way could be to use threat intelligence. And this is basically what we're gonna do in here. Since we already have the hash, we can use VirusTotal to check if we can find the domain. And usually you can see that usually in the relations tab in VirusTotal. I believe so. So let's check. Yes, it's in here. Contacted domain. So already like VirusTotal know this is a malicious executable. And probably someone in the beginning like actually tried to analyze that executable, and we have all that information about the executable. So I'm trying to see which one is actually, probably this one could be the answer. So let's try to see. And here we are, guys. Again, I think this video was a bit short and a bit fast, but again, that's because this is only an intro to memory forensic analysis, and I didn't want to make it so long. If you guys want more advanced videos, please drop in the comment section, and I would be more than happy to do that for you. And please don't forget to subscribe and like this video. Cheers, guys. Have a nice day.